review all of that today as part of this lesson. So the first thing we're going to find the area of the whole front side of the 9-4 notes is finding the area of a trapezoid. All right, so I'm going to just write you guys the formula, and then I'm going to go back through and tell you what each of the variables means. So if it's me, it's 1/2, but most of the time what I do in the calculator is type 0.5, but it's 1/2. It's a little bit faster to type 0.5 into the calculator than to type the fraction. So it's 1/2 the height of the trapezoid, and then in parentheses, this looks really complicated, but I promise it's not. I'm going to write b sub 1, which stands for one of the bases, plus b sub 2, which just stands for the other base. So whenever you have a trapezoid, remember, the only requirement for me to be a trapezoid is 2 parallel sides. So in this lovely diagram you've got right here, the 2 parallel sides would be the top and the bottom of that figure. They label it in the diagram B1 just to stand for base 1 and B2 just to stand for base 2. It doesn't matter which one of those you label which. You could switch that up. You'd get the same answer. And the height does have to run between the 2 bases. So you'll see probably like a little dotted line and a 90-degree angle. That's to let you know it's a height. A height has to come from vertex to the opposite side at a 90-degree angle, so that's what that is. And let me just write to the side here. So B sub 1 just stands for like base 1, B sub 2. The little subscripts are just to indicate that it's 2 different bases that I'm talking about. So that would be base 2. And then H is the height, or sometimes they'll call that the altitude, but most of the time I see it called the height. Okay, so you got to find 3 things to find the area of the trapezoid: the 2 bases and the height. So we're just going to grab that very first example. The bases should be parallel to each other, and you should be looking for a 90-degree angle to find the lovely height. So if I look at this diagram, there's my 2 bases, and inside the lovely figure there is the height. So we're just going to grab that information. It doesn't matter which base is which. I'll just say, okay, base 1 is 6, base 2 is 18, and the height is 9. So I'm just going to have that formula right out in front of me, and I'm just going to plug this into my calculator. So area would be 1/2, or I just do the 0.5 because it's less buttons to push on the calculator if I'm being truthful with you. We're going to multiply that by 9, and then you can add the 2 bases together, or if you just want to use parentheses in your calculator, you could just do that and have the calculator do it for you, completely up to you. So I'm doing 0.5, bless you, times 9, times, I'll just use my parenthesis keys, 6 plus 18. 6 plus 18 would give you 24, so if you wanted to do 0.5 times 9 times 24, whatever's easier for you, and then you're totally done with the question. This is 108 feet squared. Anytime you do area, remember we got to do the label as units squared. In this case, it's feet. This one right next to it is a little trickier. So I can see one of the bases, right? This base is 27. This base is not labeled, so we have to figure out the other base. And we also don't have the height, so we have to figure out the height. Here's what I'm going to do for this problem. Do you guys see the little 45-degree angle in that corner? If you see that, they're trying to get you to use a 45, 45, 90. So what I'm going to do is from this little vertex, I'm just going to do my best to draw a vertical line just straight up here. And some of these diagrams are not to scale at all, so the numbers might not be as long as the side looks. I'm going to pretend that height is right there. That'll be my height. If I do that, what I just did, because of the 90-degree angle, I just created a little 45, 45, 90. Now, I'm going to draw the little formula for that, just in case you guys forget, just right here. All right, now, if you have a 45, 45, 90, remember, the 2 sides that make up the right angle are both the same. And we labeled that with a little S for the side or the leg. This is the same. Those 2 would be the same. And then the hypotenuse is your leg or your side times the square root of 2. So, if I know in this diagram, this is 18 radical 2, does anybody know what the two legs of the triangle would be? If I know the hypotenuse is 18 radical 2, what would the two legs be? 18. All right, so I'm just going to put that. That gives me two things. That's going to help me find the other base, and it also gives me that little dotted line, which is just the height. So I've got the height. We just got to figure out the other base now. Anybody tell me what the length of the segment across the bottom of that figure is? Any idea? Or how I could figure it out? You're so close. I think you were doing it right. What do you think? Oh. It's 27 minus 18. Right, okay. So if I cut it off, it's 9 instead of 11. I knew you were doing it right. It's 27 minus 18. So that would cut that off. So this has to be, this little part of it would be 9. So that'll give us the other base. Okay, so I'm just going to write the information. So one of the bases was 27. We could see that when we started the problem. The other base, once we figured out that 45, 45, 90, we can figure out is 9. It doesn't matter which one you label which. And the height is actually a leg in that 45, 45, 90 triangle also. So that's just 18. Once you have that, you're golden. You're just going to plug it into that area formula. So area, and we're just grabbing the calculator. 1/2, the height was 18. And then we got to add the bases together, or if you just want to use parenthesis key in your calculator, you could do that. 27 plus 9 will give you 36. So if you want to multiply it like that, or if you want to just put it right like I typed it, I'm doing 1/2 times 18 times 27 plus 9. Should get 324, and then you're all done. It's not going to take you a long time. 324. Ooh, we didn't have any label on this, so I'm just going to call it units squared, since they didn't, like, we don't have centimeters or inches or anything like that. Is anybody have any questions? Okay, now this is going to be similar. I see a 45-degree angle, so I know, hey, they're trying to get me to use a 45-degree 45, 45, 90 triangle here. One of the bases I can see right away, just like across the top, we got a 17, right? All the way across here is 17. All the way across here is 23. So I got both bases. We just need the height. So one of the bases is 17. One of the bases is 23. Now what I'm going to do, just from this vertex where I got the letter B, I'm just going to do my best to try to draw a little vertical dotted line. That'll be the height, but because of that 45-degree angle that they put in the picture for us, that forces this to be a 45, 45, 90. Okay, now, I don't have any other information. This is definitely, again, not drawn to scale. Can anybody tell me any side in that 45, 45, 90 triangle? What do you think? Exactly. The bottom is 6, right? All you have to do to get that, if you do 23 minus 17, like if I cut it off right here and it's not drawn to scale, I know that. This is 6, and then also exactly what she just said, this is 6 too. I don't need the hypotenuse because we're not finding that information. You can put it if you want to. The hypotenuse would be 6 radical 2, but you don't need it. We just need the base and the height. We had both bases. That leg in that 45, 45, 90 is the height. So I don't need anything else there. I've got everything I need to do the area of the trapezoid. So we're just going to do 1/2. The height is 6, and we're going to add the two bases together. So the 17 and the 23. And again, you can add 17 and 23, you get 40. Doesn't matter if you want to do that or if you want to just type it into your calculator with the parentheses. Either way, it's up to you, whatever's faster. And so all I'm going to get there is going to be 120. And I'm done. Okay, now, I know you guys cannot see this, so please forgive. This was colored in and you can't see it. This is supposed to say 4 meters for the little dotted line right there. And it just did not come out on the copy, and I didn't realize it until this morning when I started to do this problem. Okay, so that should be 4. The dotted line should have been labeled. All right, I do have one of the bases, right? I have 3. I do not have the other base, but I do have the height. So I have one of the bases and the height. We got to figure out the other base. So one of the bases is 3. The height should have been in the problem. I'm sorry, it did not come out on the copy, is 4. So base across the bottom, that's what we don't know yet. Okay, if this was a 45, 45, 90, yes. I don't have an indication that that's a 45, 45, 90 though, but that's a good thought. Does anybody know like what this much of the base would be? 3. This is 3. It's just going to match that. Okay, now, we don't want to assume we have a 45, 45, 90 or 30, 60, 90 if we don't have that information. So there's no angles marked in here other than these 90-degree angles. I could mark right there would be a 90-degree angle. Okay. Could you find, if we could find the base of this triangle, then we could find the whole base across the bottom of that trapezoid. Anybody, it's not 45 to 90, it's not 30, 60, 90. What could I use to find that bottom piece of that triangle? Yes, Pythagorean theorem. That's all you're going to do. Okay, let me just call this a little x. Which side in that triangle that I just colored in purple would be the hypotenuse? The 5. So you got to be really careful with that. So however you want to do this, I just did a little x. The x and the 4, those would be the 2 legs. And so we would add those together squared. That would be equal to 5 squared. So we're just going to solve this real quick. So let's see, 4 squared is 16. 5 squared, 5 times 5 is 25. We would need to subtract the 16 because we're going to try to get x by itself. If I take 25 minus 16, we'll get 9. And then to get our missing side there, we just need to take the square root. Anybody know square root of 9? 3. So then where I have that x would be 3. What would the base, that base we didn't know of the trapezoid be then? 6. So if this piece is 3, bless you, this piece is 3, the bottom of the trapezoid would be 6. Okay, once we have those 3 pieces of information, we're done. We just got to plug them into our area formula. So it's 1/2. The height, forgive, that was the 4 that I didn't copy out on the diagram, right? And then we'd add the 2 bases. The base across the top is 3. The base across the bottom, we had to do some work to figure that out, but that would be 6. And you can add the 3 and the 6. That'll give you 9. Or if you want to just type it in your calculator, just put parentheses around 3 plus 6, and you can do it that way. 18, this would be meters squared, because I do have a label there. So that was, you might use 45, 45, 90. They might just give you the height, the bases. You might use Pythagorean theorem. At the bottom here, do you guys see there's a 60-degree angle? Okay, so this one is going to try to get you to use a 30, 60, 90. So let's look at this first picture. 2 of the sides are the same in this trapezoid. This 18 across the top is one of the bases. This base across the bottom, I don't have any kind of a label on this at the moment. The 14 is not going to be part of our area, but it's going to help us get there. So if these 2 sides are the same, do you guys remember that that means this is an isosceles trapezoid? Okay, so here's what I'm going to do here. If this is an isosceles trapezoid, which I know it is because of the 2 sides both being 14, if this bottom angle is 60, this bottom angle here is also 60. Okay, I'm going to drop a height just from the vertex to the opposite side at a 90-degree angle. And what that does, if you have an isosceles trapezoid, is it creates 2 little bitty identical right triangles here. And in our case, these 2 little bitty identical right triangles are both, sorry, I just kind of colored over my angle and you can't read it now. Those are both 2 30, 60, 90 triangles. Okay, now what I would tell you here, between those 2 little dotted lines that I wrote, right, this distance would just match up with the base on the top. Like that would just be 18. I'm just going to cut that off. That would be 18. I've got to figure out the height, and I've also got to figure out like the little bottom part of this base. But if I have a 30, 60, 90, let me just draw you guys the formula for that. So 30, 60, 90, remember all 3 of them are different. The short leg is what everything is based on. So in the picture that we have, the short leg would actually be like right here and right here in both of those triangles. The long leg is the short leg times the square root of 3. In our picture for that trapezoid, that's going to be the height of both of those triangles, which will be the height of the trapezoid too. And then we don't need this for the area, but the hypotenuse is twice the short leg, and I do have that information in the picture. So if that piece is 14, what would the short leg be? If you know the hypotenuse is 14, this is a 30, 60, 90, what would the short leg be? Brody, go ahead. Yes. Okay, what would the long leg be? Perfect. All right, now I have everything I need to do the area here. The 7 radical 3 is your height. Now, when I have you guys type this in the calculator, I'm just going to do it a little bit differently. But this triangle over here is identical. So that little piece there would also be 7. So all the way across here, I would do 7 plus 18 plus 7. What is that? 14 plus 18. So we're going to get all the way across here would be 32. And that's your second base. So we use the 30, 60, 90 triangle to help us figure that out. All right, so we got everything we need. Base across the top is 18, so that's one of the bases. The base across the bottom is 32. Now the height is kind of weird here, and we're going to leave this in radical form, because if you have a radical like this, we have 7 radical 3 here, we're going to leave it like this. So here's what I'm going to type in the calculator. I'm going to do 1/2, and I'm going to multiply that. My height is 7 radical 3, and my 2 bases we're going to add together. I'm going to do 18 plus 32. Okay, I'm going to type this almost exactly like I just wrote it. I'm just going to leave out the radical 3. I'm not going to put that as I type this into the calculator. I'm going to leave that out. So I'm just going to type 0.5 times 7 times those 2 bases added together, 18 and 32. I just left the radical 3 out of it, but I'll put it back in as I get done with the problem. So just multiply that, and I got 175. Then all you have to do to leave it in radical form is just put that radical 3 next to that. You just don't involve that as you do the process. Just put the radical 3 back in at the end, and that's in simplest radical form. This guy was in inches, so we're going to write inches squared here for our area. Okay, now I have also, the problem next to this is going to also review 30, 60, 90, but it's a little tiny bit different information. This is not an isosceles trapezoid. So I don't have this base labeled, but I do have the base across the bottom labeled, and I'm also missing the height. So we're missing 2 things here. So base 1 across the top, I don't know. Base 2 across the bottom is 16, and then the height, I don't know. So I'm missing 2 things here. But we have a little 30, 60, 90. And it's really similar to this question we just did. They gave me the hypotenuse is 10. Does anybody know what the short leg, which would just be like this little piece here, if this is 10, what would that little piece be? 5. Okay. If I know that, I know the whole base across the bottom 16, right? But if I know that piece is 5, could you tell me what the top base is? The height is 5 radical 3. Yes. That we need that. There's our height, 5 radical 3. Okay. Does anybody tell me what the base across the top of the whole figure would be? So I know the whole bottom of this is 16, and I know this much of it's 5 from that 30, 60, 90. What would this top piece end up being? Lachlan, what do you think? Exactly. How'd you get that? Yes. So if the whole thing is 16, if I cut this off, you just do, to get that 16 minus that 5, the leftover is 11, and that would match up with the top, because we just cut that triangle literally off. So all I have to do once I get that, this is a little trickier because it's got that radical. I'm going to do the 0.5. My height is 5 radical 3. I'm just going to include the 5 when I multiply this out, and then my 2 bases, one of them's 11, one of them's 16. So just as you type this in the calculator, don't involve the radical 3. Type everything else like we just were doing in the last couple questions. Do half times the 5 that's out in front of the radical, and then times the bases added together, 11 and 16. And this is not a nice number, that's okay. We're just going to write 67.5, and then you just put the radical 3 back into the answer. Just right like that. We just didn't include it. This leaves it in radical form. This guy would be feet squared for your label based on the diagram there. All right, those are all trapezoids on the front. A lot of review with 30, 60, 90, 45, 45, 90 Pythagorean theorem. What we're going to do on the back is rhombuses and kites, and the reason we're going to do them together is because they have the same area formula. Okay, so there's a rhombus that's drawn kind of right here. And remember, all I have to be, a rhombus is a parallelogram where all 4 of the sides are the same. And then a kite, which I have kind of over here in this picture, a kite has 2 consecutive sets of sides that are the same. The kite does not have parallel sides or anything like that, like a rhombus would. But the other thing that a kite and a rhombus both have in common is that their diagonals are going to run into each other at 90-degree angles. Okay, now, the formula for this, and I'll kind of explain it with the kite here in 1 second. It is 1/2, and what you do there is you multiply the diagonals together. They use the letter D to represent the diagonal, so they're going to take diagonal 1 times diagonal 2. If you've got a diagonal, like right here, one of the diagonals, they just have a label, but a diagonal connects 2 vertices that they're not right next to each other. They call them non-consecutive vertices. So the vertices are across from each other when you have a diagonal. So there's my 2 diagonals there. If I can find those 2 segments, then I can just multiply them together and cut it in half. Now, the reason that we cut it in half, let me kind of show this to you guys. All right, so I'm going to come over here. This is a kite that has a rectangle around it. Okay, here's what I'm going to show you. Within the kite, do you guys see there's 4 little bitty rectangles inside the kite? Okay, now, in each corner, inside the kite, I'm not going to color this. Outside the kite, that I just colored, and the triangle right next to it, those are identical. All right, kind of same thing here. You've got the triangle inside the kite, and then you have an identical triangle right there. These 2 triangles, this one would go with this one would go with this one. So in total, I have 8 little triangles there, but I only want the area of 4 of them if I were to find the area of a kite. Would you guys be okay with me saying, here's one of the diagonals? Would you agree that that would just match up with either the base or the top or the bottom of that rectangle? That's all that is. Okay, so it's that side of the rectangle, and then the other diagonal goes right through here, but that would match up with those 2 sides of the rectangle. So if I did, just for the rectangle there, this whole side, they labeled this one diagonal 1 and this one diagonal 2. So if I did those 2 multiplied together, remember, I don't want all 8 of these little triangles, I just want 4 of them. That's where the 1/2 comes from in that formula. So I just did base times height for that rectangle, would give me the whole rectangle. If I cut it in half, it just gives me the area of the kite. So that's where the 1/2 comes from. That's what this little blurb down here explains if you want to read through that. But you can encompass that kite in a rectangle, create that situation, and it's going to be 1/2 the 2 diagonals. That's really all you have to remember. So if you guys come down here to the kite, all right. Remember also, a kite and a rhombus, you're not going to need that here, but their diagonals intersect at 90-degree angles. If I go from L to N, let's say that's diagonal 1. That connects 2 non-consecutive vertices. 1 parts 3, 1 parts 3, just added up, that's 6. From K to M, let me just call that diagonal 2. It doesn't matter. You just need each of the diagonals. You'd have to go all the way across there. This piece is 2, this piece is 5, add that up, that's 7. Once you have those 2 pieces of information, you're golden. We're just going to do our area, I'm going to do the 0.5 again instead of the 1/2. 0.5 times 6 times 7. And just type that right on into your calculator. This should give you 21 meters squared for your area. All right, I don't have any labels on this one. This diagonal, all the way across there, I would do 18 plus 10. So let's say that's diagonal 1. That would be 28. All right, now diagonal 2, I only have that part of it labeled. I have diagonal 2. Part of it is 7. Does anybody know what that other piece would be if this is a kite? It's also 7, yes. Now, it's not this, the diagonals don't bisect each other, okay? So, like, this is 18 and this is 10. Those are different. But if you're going this way, there is a diagonal that gets bisected. This is 7 and 7, just like back here. This was 3 and 3. The one that goes up and down there, that is going to be exactly cut in half by that other diagonal. So the other diagonal, 7 plus 7, this guy would be 14. So then to get my area, we're just going to do 1/2. One of the diagonals was 28. The other one was 14. We're just going to multiply that stuff together, and we're going to end up with, this should be 196 centimeters squared. Okay, and then let me have you guys, we're going to do rhombus next. It has the same formula, but let me have you, do me a favor. This did not come out. Change this to say 12 radical 3. Each one of these is a rhombus, but it looks bad on the copy. So change that to say 12 radical 3 on that picture real quick. So we did 2 kites, now we're going to do 2 rhombuses. So I have immediately one of the diagonals labeled in this first picture is 24. And what can you tell me about this? If this is 15 and this is a rhombus, can you tell me the other sides in the rhombus around the outside? 15, right? So every single guy here, each one of these would be 15. Now, I need the other diagonal. So the other diagonal would go, I'm just going to kind of draw it. I'm not trying to cancel out the 24. I'm just trying to draw the other diagonal in. Now, a rhombus, the diagonals bisect each other. So they're not necessarily the same length, but like this piece and this piece would be the same. And then I'm going to go 1, 2, 3, 1, 2, 3. Those would be the same. Diagonals of a rhombus are also perpendicular, so these would be right angles. Okay, now you guys don't have to do this, but let me just kind of come down here real quick and draw this again so it's not so garbaged up. Now, if this entire diagonal was 24 and I draw the other one in, that 24 is going to get split in half equally to 12 and 12 because the diagonals bisect each other for a rhombus. Now, the little other diagonal I drew in, I didn't draw very well, but these two pieces would also be the same length. I'm just going to call that X. And we know all the way around the outside of the rhombus, all those sides are the same, so all those sides would be 15. If you have a rhombus, if I had done a better job drawing this, pretend I did, there's 4 little triangles in here, and each one of them they're congruent to each other. They're just kind of rotated around to form that. Does anybody know, because we need the other diagonal, like how could I go about finding the other diagonal? It's just Pythagorean theorem. That's basically that's all I'm trying to get you at. Now, be careful with this. The 15, the side in the rhombus, that should be the hypotenuse because it's across from the right angle. I just used an X. That will be half the diagonal. So we're just going to do X squared plus 12 squared 15 squared. I highlighted one of those little right triangles. You could make that argument for all the little right triangles in that diagram. This guy's going to be 114 when you square 12, and 15 squared is 225. So I'm going to take 225, subtract the 144. And we'll have to take a square root, but it should be a nice number. So 225 minus 144 is 81. Does anybody know square root of 81? 9. This is 9. Okay, now, this is important. So in the picture here, right, I have two little segments that say X. So like this piece would be 9, this piece would also be 9. So the entire other diagonal there, whoops, diagonal 2, we'll just call it, would be 9 plus 9. So the whole thing would be 18. So make sure you get the whole diagonal, because if I do that little Pythagorean theorem, I just get half of it. So just be careful with that. Once you have the two diagonals, you're done. You're just going to do that 0.5, and then one of the diagonals, 24, they gave that to us in the problem. We had to do a little bit of work to find the other one to be 18, but we got Pythagorean theorem on our side there to help us do that. So 1/2, one of the diagonals is 24, the other diagonal is 18. It does not matter the order you multiply those in, they should give you the same answer. So I got 216 centimeters squared. All of these are area would be units squared. All right, now this one also a rhombus. So all these are right angles, and all the sides around the outside will be the same length. And we put in that 12 radical 3 because that did not come out on my copyright. Does anybody know what this piece would be? It would also, exactly. If you have the two diagonals, they bisect each other. So if one side's 12 radical 3, the other side's the same. Now, what would that, let's call that diagonal 1. What would that entire segment be? Just leave it in radical form. If we put that together, added those two sides up, what would you write down for that whole diagonal? 24. And then don't change what's under the radical. If you're adding it, it would be like 12x plus 12x would be 24x. You have 12 roots of 3 plus another 12 roots of 3, so you have 24 roots of 3. Now, this one also, let me draw one of these down here. So they're telling you this is a 30-degree angle. If you have a rhombus and you have the diagonals bisect each other, and they also bisect the opposite angles. So all these little angles here would be 30. So each one of those little triangles is going to have a 30-degree angle. And I know this is 12 radical 3, and if that's 30, and then diagonals are perpendicular, that's 90. That forces that other angle to be 60. So you got a little 30, 60, 90. All right. Now I'm going to write you the formula. This is your short leg. Where you got the 12 radical 3, that is the long leg in a 30, 60, 90 triangle because it's across from the 60-degree angle. So that should be your short leg times the square root of 3. And then your hypotenuse, which we're not going to need that for this question, but that would be twice the short leg. If I know this is 12 radical 3, what would the short leg be? If I know this, what would this be? 12. All right. Now, that 12 would go here, and these two triangles down here also, that would be the short leg, would be 12 there. So the entire diagonal, we're just going to take 12 and 12. I'll call that diagonal 2. That would just be a plain 24. It's just 12 and 12. The other two sides were 12 radical 3, so that's why that has a radical next to it. To get your area, you're done. You just have to do 1/2. One of the diagonals is 24. The other diagonal was 24 radical 3. So this is kind of similar to that one question we did on the front. I'm going to leave this in radical form. So I'm just not going to include the radical 3 when I type this in my calculator. So we're just going to do like 0.5 or 1/2 times 24 times 24 and write the radical 3 next to it. That way it leaves it in simplest radical form. So this would be 288, and then I'm just reintroducing, because I didn't include the radical 3, but just put it back in, because you're just multiplying everything together there. And then this guy is, we had no label on this, so units squared. Is anybody having a question? Yes. Just units squared. Yeah, if they don't give it a label, it's units, because you don't know. Okay, now last question. This one is also a rhombus, and I just gave a picture of, this is supposed to be a rhombus, so rhombus, all four sides are the same. They don't mark anything in the picture at all. They just tell you the perimeter is 116 centimeters, and one of the diagonals, I'll just call it diagonal 1, is 42. How could I use the perimeter to help me label any part of that rhombus? Like if my perimeter is 116, what can I get from that? Exactly. Just 116, just divide that by 4. Okay, I don't know what that is off the top of my head, so let me see. 116 divided by 4, I got 29. So this is 29. So we have to split that perimeter evenly between each of the sides because we got a rhombus here. So these guys are all 29. All right, now, totally doesn't matter where you draw this. I'm going to draw in one of the diagonals, just kind of best I can. Diagonal connects two non-consecutive vertices. And I have another diagonal. I'm going to do both of those in there because we'll need both to do the area. Now, if one of the diagonals is 42, right, 42, I'm going to take 42 and I'm going to cut that in half. And I'm just going to write this piece would be 21, this piece would be 21. The whole thing would be 42, but when you have the diagonals of a rhombus, they bisect each other, so they cut each other in half. So if one of them is 42, then on either side of where they intersect would be 21. Okay, the other thing we've got here is the diagonals of a rhombus are perpendicular, so we got right angles here. And then on this, the diagonals bisect each other. So those two sides that I don't know anything about that diagonal, I know they'd be the same. So maybe I call that x and x. I got to get this other diagonal to be able to do my area. Anybody know what you would do to figure out either one of those x's? We've used it today. It's not 45, 45, 90, not 30, 60, 90. What could I use if I've got a right triangle? Pythagorean theorem. Yes, I knew you were trying to say it. Okay, any one of these little triangles, I'm going to just color in one of them. Any one of these four little triangles are exactly congruent to each other. They're just rotated around in a different orientation to create that rhombus. But I'm just going to use Pythagorean theorem. Now the key here is the 29, the side length, is across from the right angle. So that would be the hypotenuse in your right triangle there. So I'm trying to get the other diagonal. I'm going to do 21 squared plus x squared has to be equal to 29 squared. We got a little right triangle. Now, these numbers are a little big, but you get a nice answer when you do this. This is 441 plus x squared is equal to 29 squared is 841. I'm going to subtract 441. So we get x squared is equal to 400. Anybody? You can do it on your calculator. Anybody know that off the top of their head, square root of 400? It's 20, yeah. So, now don't forget, when you're here, this piece is 20, this piece would also be 20, so the entire diagonal would be 40 when you add that together. So just don't forget that. You got the piece, but the whole thing would both of those would be 20, so the whole thing would be 40. Now, we're done pretty much. We just have to plug it into our area formula. 1/2, one of the diagonals is 42, one of the diagonals is 40. So I'm just doing, on my calculator, just doing 1/2 times 42 times 40, and you should get 840. Now, in the directions, they told us this was centimeters, so I'm going to put centimeters squared as my label for my area. Does anybody have any questions?